Most timber frame buildings are traditionally held together with wooden pegs, and in roundwood timber framing that's no different. So what we're doing here is making some pegs for the building. We're using oak. This is oak that I actually cut over a year ago, and I've been allowing to dry. The reason for that is we want the pegs to be more seasoned than the frame, so as the frame dries out it will shrink tight onto the pegs and therefore holding the building together that much better. Traditional sort of green oak frames use a process called draw pegging, where you have a tapered peg, and the tapered peg is hammered in between two holes which are offset, so as the peg goes through it draws the joint together. Now with roundwood timber framing that's not so easy, because we've got the this third dimension of this extra curve in the timber. So the process we use is creating a cylindrical peg, and we do that by first of all ripping down the oak into a square section, and then, as Mark's doing here, start to work it on the shaving horse, using a draw knife to take off the edges and work it down so it's then ready to go into something we call a rounding plane. And a rounding plane is basically a giant pencil sharpener. And what it does is, by working it down, this little spoke-shaped blade will turn this into a nice even cylinder. These planes come in different sizes. This one is 25mm, so I'll know the exact size of peg I'm getting, which will come out this end. So it's literally a process of just working the rounding plane down through the oak and getting a peg of the perfect cylindrical diameter we need for jointing the timber. These rounding planes we get from Asham Crafts, and Asham Crafts is run by a great character called Peter Hindle, and Peter's been supplying me these now for about 15 years. Peter worked with these quite early on with Fred Lambert, making traditional country chairs, which Peter still makes, and these to us are the real essential tool for peg making.
They were made originally as wood tools for making rungs on fruit picking ladders. We eventually developed them into a casting, and using a spoke shave blade works very efficiently. We used them to begin with by hand, by rotating them on a piece of wood to make a round dowel. Eventually then the originator, Fred Lambert, decided he needed some mechanical means. Now a lathe, wood turning lathe, was far too fast. So what he did, he developed a little gearbox system where we could slow the speed down, right down to about 60 RPM. So we used a little gearbox out of a three-wheeler Reliant, and it had, of course, the 4 speeds, and in the bottom speed, with a 4-to-1 reduction with the pulleys, from an electric motor we got a speed of about 60 RPM. Put it into the 4th gear and you've got 400 RPM, which is all right for very, very thin dowels. So the thicker the wood, the smaller the speed, slower the speed you need in the gearbox.
Now obviously making pegs as we do is a lovely way to do it, each one individually by hand, but it is quite a slow process, and when we're on a big build we might be needing 300 to 400 pegs. So having some way of speeding up the process has always been something we've been looking at, and Peter has made this wonderful turning head for us, which is just a great piece of DIY engineering on his part. We've got this lovely Robin Reliant gearbox that he's pulled out of an old second-hand car and got that going to give me the speed of turning on this machine. He's also managed to find a second-hand 110-volt motor, so we can use it through a transformer, so it's actually reaches site safety for using on building sites. And it can really speed up the whole process of making pegs.
The kids used to like doing that at school, And then one boy, he got it caught up here in his trousers. You can imagine what the other kids thought to it.
For drilling out the holes, there's a range of different drills you can use. This is probably the most extreme, a two-stroke petrol auger drill. Useful when you're working sort of away from any power supplies or when you've got a lot of holes to do. But you could also use a bar auger or Scott's eye auger and do it manually that way. And then high torque, low speed electric drills are also fine for doing this type of drilling. Once the hole is drilled out, we then knock in the peg. And that's quite a comfortable fit. In order to make sure that this peg can't slip and the joint can't open up, we then wedge the peg from each end. This is an oak wedge we made earlier. I'll need to put one in the bottom before I knock that one home. Once the frame is completed on the framing bed, we then move the frame over to its final position before it's going to be raised, so the feet are sitting on the pad stones. The frame is dismantled and brought over in pieces. Sometimes we move the main A-frame as one piece, sometimes we move all the poles individually and then reconstruct the whole frame in situ. One of my main interests with roundwood timber framing is seeing how these buildings are going to be useful in the future. I believe in 40 to 50 years' time we'll find it a lot more difficult to build buildings which involve bringing in materials from long distances and use a lot of high energy equipment to construct. Hence, one of the beauties of roundwood timber framing is that you can go out into your local forest, harvest the trees and build with them in the round. But we also need to look at species that are going to be available and suitable as temperatures start to warm up. A lot of the trees that we're familiar with now might not be so healthy or so useful in 40 to 50 years' time. So we need to look at ones that are going to adapt well to our climate. One such tree is the black locust, Robinia pseudoacacia. And this tree has many great properties for roundwood timber framing. To start with, it's a nitrogen fixing tree, so it's going to benefit other trees around it in the forest. And then there's the timber itself. In North America, where this tree grows a lot, they describe it as lasting a year longer than stone. So this is a really durable timber. We're looking at a timber as durable as oak at least, so has huge possibilities for building without the need for any treatments of the timber. It coppices, it suckers, and it's fast growing. Really is a tree I think we're going to see a lot more of in the future in our forests in the UK. When I stand here in amongst the frames at this stage in the build, you can still see the whole form of the trees, the whole shape of the roundwood that's been growing, and yet within this we've actually got some very strong jointing techniques. What I like about roundwood framing is, one, that you keep that form of the tree in its purity, but also you're able to use timbers such as these, which are quite small dimension as regards age of trees being growing. Most of the trees in here are about 30 years old. And when I look to the future, we're going to have to look at how we're going to be able to build buildings using trees that maybe we don't have the equipment to saw up down into sawn square edge timber. We're going to have to start thinking about tree species that are fast growing, that may be more adaptable to global warming, and this is where roundwood timber framing has a really key element to play, I think, in the future. This is an area we coppiced this winter, and what I'm standing by is the regrowth of hazel coming back for the first time in about 40 years. This area contained a mixture of oak standards, which are the taller trees, over the top of ash coppice, hazel coppice and chestnut coppice. The ash we use for wind bracing in the buildings, the hazel for wattle and daub and woven panels, and the chestnut for the main frames. The oaks that are the standard trees here, we've also felled quite a few of those, and they'll get planked up and used for the cladding and the floorboards. So while I'm utilising that material to build with, the new growth of the coppice is coming back, creating more product for the future. You can see on the bottom of the posts here, we've painted the bottom, and this is with a mixture of wood tar and citrus, and this just seals off the end grain of the timber. If you imagine with this, where the end grain of this timber hits this padstone, that's the most likely point for moisture to try and absorb and work its way back up into the pole. So this is just to give it extra protection. We also, once the frames are up, we use a couple of bottle jacks, and we'll actually put the bottle jacks under this floor support, and we'll lift the frame up a few mil, and we'll slide a bit of slate under, a bit of roofing slate, and then trim that round. So we'll have the protection of this wood tar plus the slate, which just lifts it a little bit up above the padstone. I'm not expecting to get moisture working its way onto the padstone, but if it does, we've made sure that these are lifted that much higher to make sure that it doesn't get any moisture sucked up through the end grain.